Salam and welcome everyone. So today we're going to be working on the question on the screen that says the vapor pressure of dichloromethane at 24.1 degrees Celsius is 53.3 kilopascal and its enthalpy of vaporization is 28.7 kilojoule per mole. Estimated temperature at which its vapor pressure is 70.0 kilopascal. So the first thing you have to note is that we're going to break down this question. We're told the vapor pressure of dichloromethane being the molecule, or you can say the chemical or the sample that we're working with in this question, at 24.1 degrees Celsius is this. So we're told that at this particular temperature, it has a vapor pressure of 53.3 kilopascal. And we're told the enthalpy of vaporization, which is just basically um, going from liquid to gas or from liquid to vapor, is 28.7 kilojoule per mole. Now we're told to estimate the temperature at which its vapor pressure is 70.0 kilopascal. I wanted to mention for anyone who's confused, this is not a question where you have to solve something and then get an unknown and then use that to solve the other part of the question where it says estimate the temperature at which its vapor pressure is 70.0 kilopascal. That's not what's going on here. What they're actually expecting you to do is for you to use the formula, which is just simply called the Clausius-Clapeyron formula. So these are the two ways the formulas can take. And we're just going to use one for this particular question. So you can either have the formula as the natural logarithm p divided by p star, okay, is equal to negative change in enthalpy of vaporization, okay, divided by R, which is a gas constant, times 1 over temperature minus 1 over temperature star. That's one formula, okay? And or you can have the second formula as this: pressure is equal to P star, okay, E. So we just basically did the natural logarithm of this one. So E raised to the power of, let me write it properly, E raised to the power of the change in enthalpy of vaporization divided by R, okay, 1 over T minus 1 over T star. And that is basically, so it's either or, it's either one of this equation for this particular question. So for this particular question, I am going to be using the top formula. And yeah, that's it. I wanted to mention something before we start. You see, we have P and then we have P star. You see, we have T and then we have T star. What this is saying is that P star, okay, very important for you to note this, is the vapor pressure. Let me just say VP is the vapor pressure when the temperature, which is TMP, is T star. Okay. So what I'm trying to tell you is that P star, okay, is related to T star. And P, okay, in the formula is also the vapor pressure when T is the temperature, okay? When T is the temperature. So what is this telling you? T is related to P, or P is related to T, whatever you want to say. So this is what this is just telling us. This is basically Clausius Clapeyron method. So now it's now time for us to like write out our parameters. So we have the P star. So we have the P star. If you go back to your question, is the vapor pressure of dichloromethane at 24.1 degrees Celsius is 53.3 kilopascal. So the P star is going to be what? 53.3 kilopascal. So that's what I'm working with. And then we were told that that happens at 24.1 degrees Celsius. So T star is going to be 24.1 degrees Celsius, which I am going to turn to Kelvin. So plus 273.15. So T star becomes 297.25 Kelvin. And then, of course, pressure. Let's continue. We're now told the enthalpy of vaporization is 28.7 kilojoule per mole. So enthalpy of vaporization is 28 what 0.7 kilojoule per mole. Okay. Then the question goes further and says, estimate the temperature at which its vapor pressure is 70.0 kilopascal. So estimate the temperature. So we're looking for T when the pressure, so the vapor pressure, you can see it's just P now, not P star, is 70.0 kilopascal. Goes 70.0 kilopascal. So basically we have all our stuff out. So we just have to write out the formula again. So which is just ln. By the way, I have my notes beside me. So don't be wondering why I'm not going back and forth with the page. I have my notes. So I'm just going to rewrite the formula here. ln P over P star is equal to negative the change in enthalpy of vaporization divided by R. You just 1 over T minus 1 over T star. So yeah, so you have ln P is just simply 70.0 kilopascal, okay, divided by 53.3 kilopascal, okay, is equal to negative. The change in enthalpy of vaporization will be 28.7 kilojoule per mole, okay, divided by the gas constant, which is a constant. So that's just the regular 8.3145 joule per mole Kelvin, okay. So that is just this times 1 over T. Remember, it's temperature we're looking for, minus 1 over T star. And we know our T star to be 297.25. So that would be 297.25 Kelvin. So yeah, that's it. That's basically what's going on. You cancel out the kilopascal, cancel out the kilopascal. So we ln 70 divided by 53. So let's just write 70 divided by 53. When you put it in the calculator, you end up getting 1.31332, okay, is equal to minus 28.7 times 10 raised to the power of 3 joule, okay, that's it, per mole, okay. I just want to write this step by step, divided by 8.3145, okay, joule per mole Kelvin. Of course, now thank God, we can cancel out the mole, the mole. So what we have is just the Kelvin here. Our work is still not done. So we have times 1 over T, okay, minus 1 over 297.25 Kelvin. So ln 1.31332 is equal to 28.7 times 10 to the power of 3 divided by 8.3145. When you do that calculation, you end up with negative 3.4518 times 10 to the power of 3. Okay. We now know in chemistry, right? No, we don't know in chemistry. We know in math, right? That 1, okay, divided by 1 over a denominator, so in this case Kelvin, so 1 divided by 1 over Kelvin is the same thing as 1 times Kelvin over 1, which is just the same thing as Kelvin. So that's what we're going to put here. So we end up having Kelvin here. So we have that, and then of course you multiply 1 over T minus 1 over 297.25 Kelvin. So ln 1.31332 would just simply be 0.272558 is equal to minus 3.4518 times 10 to the power of 3 Kelvin times 1 over T is the same thing as 3.4518 times 10 to the power of 3, okay, Kelvin divided by T. So I'm expanding, by the way, I'm opening the bracket, minus 3.45, okay, 3.4518 times 10 to the power of 3 Kelvin times minus 1 over. So it's going to be minus here. And of course, minus here, it's just going to be plus. So it's just going to be plus 3.4518, okay, times 10 to the power of 3 Kelvin divided by 297.25 Kelvin. And you guys might be wondering why I'm breaking it down a little so like slowly. Well, I'm trying to make sure everyone who watches this video understands. So now we're going to continue. So that'll be 0.2725558, okay, minus 3.4518 times 10 to the power of 3 Kelvin plus 3.4518 times 10 to the power of 3 divided by 298.25. That's just going to be 11.6125. So that's it. Now we can just continue. We can put like terms here. This is the only one that actually isn't a like term. I forgot to say divided by T here, divided by temperature. I apologize. But we just bring like terms together. So you have 0.272558 minus 11.6125 is equal to negative 3.4518 times 10 to the power of 3 Kelvin. So yeah, that's what you do. So you end up with minus 11.339942, okay, is equal to, so this is for this here, negative 3.4518 times 10 to the power of 3 Kelvin divided by temperature. So you cross multiply. And when you cross multiply, you have a negative 11.339942 temperature is equal to negative 3.4518 times 10 to the power of 3 Kelvin. So you cross multiply, of course, because you cross multiply, this one is the variable. So we make it a subject or formula, or we solve this question in terms of T. So we're just going to divide both sides by 11, negative 11.339942 divided by here by 11, negative 11.339942. Of course, you cancel out this one, you cancel out this one. So you have the temperature is equal to negative 3.418 times 10 to the power of 3 divided by negative 11.339942. Of course, you turn this negative to positive, and when you put that in the equation, you end up with 304.39309 Kelvin. Yeah, that's basically the temperature that we're asked to solve. But our work is still not done because we are chemists and we are scientists, so we have to pay attention to sig figs. We go back to our question, we see that the lowest number of significant figures in the different numerical values were given in the question is 3. We have 24.1 3 sig figs, 53.3 3 sig figs, 28.7 3 sig figs, 70.0 3 sig figs. So our final answer has to be in 3 sig figs. So you have this here. So temperature is just going to be approximately 304 Kelvin. And this is the answer to this question. If you would like to see more videos, I actually do another question very similar to this on my channel, which is just this. It is all from the Atkins Physical Chemistry 11th edition. I have solved a bunch, over 90 thermodynamics portion of the Atkins Physical Chemistry 11th edition textbook. So make sure you watch my channel and click on the playlist to learn and succeed. I also want to mention this. If you're a student struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I am the tutor for you. I help students succeed in all your STEM related courses, as well as improve your academic life. So if you would like to succeed and if you'd like to book a session with me based on what you have seen on my channel, make sure you email me at shohabitutoring@gmail.com. You can either get a one-time session or you can just simply request an ongoing tutoring. So yeah, make sure you email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.